Hi there, this is Penelope. This is the second of the recorded versions of the live video MG5004 T2C1 Part 2. Okay, I've got a question. The question's not quite right there. It's asking you to find the mass of a cylinder, mass of a pipe. The external diameter is 205, not 160, and the internal diameter is 160. Okay, you know the area of a circle is pi d squared, so we can write the volume as pi over 4 times the difference between the diameters. And times the height. Now the mass is going to be the volume times the density. And what we find is that the meters cubed all cancel out. So the mass is equal to 0.25, so that's where the quarter's gone, times 5500 times pi, times the difference in the diameters, times 1.5, and that's now in kilograms, and doing the arithmetic on your calculator, approximately 106. I think that was for the working. Okay, now the next one is actually I know what the problem is. We need to delete that one. We will do it later. Now have a look at this next one here. Shows that the area of the shape is what it's given as there. You need to look up that the area of a trapezium is the height, in this case, times, well, we're going to find the answer. Look up the area of a trapezium. Okay, so we've got A to B there, and if we do that to B there, then it tells us that that's 30 centimeters along there, and the height is what we don't know. The slanty sides is 20 centimeters. Okay, so AB squared is going to give us h. It'll be 20 squared minus h squared. So AB is going to be square root of 20 squared minus h squared. Now, the longer side of the trapezium is going to be 30, because that's the middle bit, plus 2 times whatever we've just worked out that AB is. So it's 30 times, sorry, needed a cough. So that the area is going to be, no, what were we doing? We were doing the longer side. The longer side is going to be 30 times, that means that the area is going to be 30 plus 2, 20 squared plus, it's minus h squared over 2 times the height. And if we work that out, it is what we're looking for. And make sure you can follow that through. Okay, the next one, another physical one. We need to remember the volume of a cone. So the volume of a cone is going to be a 12th pi d squared h. So that means that the height is going to be 12 times the volume over pi d squared. Okay, so what do we know? We can write that as, now d is 2r, so v equals pi times 2r squared h over 12, which we can rewrite as pi r squared h over 3. So that's the volume of a cylinder. Okay, sorry, of the cones. Now, let's put on all the numbers. The volume of the cone is equal to 1/3 of 50 squared times 150 millimeters, and that's cubed, and the volume of the cylinder is equal to pi times 40 squared times h, and it's in millimeters. Now if the volume is going to be the same, then these two have to be the same. So what we've got is that 1/3 of 50 squared times 150 has got to be equal to, rearranging those, we get that h is equal to 1/3 times 50 squared times 150 over pi times 40 squared. Do it in one calculation and you get that h is approximately 78.125 millimeters. Okay, so that's the one we don't do. Now, rearrangement. Rearrangement, you need to find L, so we need to rearrange that to find L. Okay, so we'll go through it fairly quickly. T over 2 pi squared is going to be L squared plus 4t squared over 3g times r minus t, which is, now we're going to multiply both sides by 3g minus 3g times r minus t. So then we've got that L squared equals, so t over 2 pi squared times the bottom line I don't need to put that in brackets, or maybe I do, minus 4t squared. So then L is going to be the square root of all of that. Let's do it in terms of r. So we can go the same way. We can do t over 2 pi is equal to L squared plus 4t squared over 3g times r minus t. So then, just this time multiplying by 3g, that's going to be L squared plus 4t squared over r minus t. Now we're going to flip it so that we get the r, the thing that we don't want, on the bottom. So the thing we do want on the bottom. We're going to run out of space. Okay, rearranging that will give you that r is equal to 4 pi squared L squared minus plus 4t squared over 3gt squared plus t. Okay, make sure you can do that. Transpose the formula r over r to find p. Okay, let's square both sides. Cross multiply. Multiply it out. Now we can put all the f terms on one side and all the p terms on the other. a capital R. Oh no, that's a little r. So I've got capital R squared F minus that. So this then should be a capital R squared P. Okay, on the left hand side then we can factorise out F and on the right hand side we can factorise out P. And then dividing both sides by r squared plus r squared. You need to watch what I write. Divided by r squared plus r squared. And we're done. Okay, this is an engineering type question. What we have to do is rearrange it and then find L. So simple, relatively simple rearrangement gives us that 8s squared over 3d plus d equals L. So substituting the numbers that you're given in the question. So L equals 8 times 0.8 squared over 3 times 1.75 plus 1.75, 2.725, and that should be in metres. The next question, make gamma the subject. So now the 4 belongs to the z, it's actually z4, it doesn't belong to the root. So we're going to go, we can do fairly big chunks. A times mu over n rho cz to the 4th equals the square root of lambda 5. So lambda equals the 5th root of all of that squared. Got it. Oops, that should be a 4. Okay. The last question, should be able to get it in. We need to rearrange the formula that we're given to find V. I'll leave that to you to do on your own. So you should get that V is equal to the square root of d dgh over 0.3 L. Now when you put the numbers in, you get that V is equal to 2 times 0.30 times 9.81 times 0.712 over 0.03 times 150, approximately equal to 0.965 in the appropriate units of meters per second or whatever. Okay, that's the end.